When it comes to performance tuning, one of my questions is always, well, what can I learn from the execution plans from this query? Let's take a look now at what plans are we getting when this is slow and when it's fast, and what we can learn from them. We're going to first dig into the execution plan for the query using the user database table. I've got actual execution plans turned on using this button. You can also do Control-M to enable that. And now I'm going to execute the query that loads 1,000,000 rows into a user database table and then updates 800,000 of them based on the parameter I've passed in. This did have the expected duration. We have about 1.3, 1.4 seconds of duration for the update statement this time. Looking at the execution plan for the procedure, at the top I've got a plan for the insert, for inserting the 1,000,000 rows. That makes sense. That's not really what we're concerned with. For the bottom, I got what's called a wide plan for the update of the rows. For a wide plan, I have one step here that's doing a clustered index seek to find the rows it's going to update. And when I look at the properties of this in my actual plan, I've got the clustered index seek highlighted there. I can see actual I/O statistics for this. I did my 53,500 logical reads on that operator doing the clustered index seek. Okay, that finds the rows. Here's the clustered index update. Looking at the actual I/O statistics for that operator, I have already found the rows. It did not have to do any additional logical reads for it. On this fast plan for the user database table, all of my I/O shows up on that clustered index seek. Do we see anything different when we use the temporary table? Well, let's find out. I've still got my actual plans on and I run the procedure again. It inserts 1,000,000 rows into the temp table, then updates 800,000 based on the row ID value I passed in. And once again, the duration of the update of the temp table is much slower, 5.5 seconds there. Looking at the execution plan for this, I do have a similar looking plan. I have a clustered index seek broken out here as its own operator. Well, let's look at how many logical reads that operator had to do. Its actual I/O statistics, this isn't the same at all. We did 2.4 million logical reads. Like, wow, we did way more logical reads finding the rows to update in the temp table. And I did run some additional queries to say, do I have way more pages in this? Is my temp table getting a lot of empty pages in this? And it wasn't. I found that my temp table was in fact getting the expected amount of pages that is very similar to the amount of pages in the user database table. But wait, there's more. If I click on the clustered index update and I look at its I/O, this is different as well. The clustered index update operator is also showing that it had to do logical reads, and not just a few. Millions of logical reads. We already found the row. Why am I having to reread the rows again? So there's definitely something different when we dig into the I/O characteristics of the plan. Well, the table variable is also fast. Let's look at the table variable, who, as long as we don't have a recompile hint, is just as fast as the database table. And its update execution plan is different. It has a narrow plan. Looking at this, you're like, the table variable is so fast, it doesn't even have to find the rows. It just mystically knows where they are. Well, what it has done is it's done a narrow plan and collapsed the step where it finds the rows into the clustered index update operator. If I look at my tooltip on this, notice that I do have a seek predicate on my clustered index update operator. It does still have to find the rows. It just has simply taken that operation and it's not breaking it out as a separate operator with that compute scalar in the middle. Instead, it's like, no, I'll just seek as I do, in the update operator itself. It's just chosen a different style of execution plan based on different row estimates because it's a table variable. What about the I/O? Looking at the properties of this operator, the actual I/O statistics are very similar, of course, to what we get for the user table. We saw that before in the statistics I/O output, but now that I'm looking at the actual plans, I'm able to see it on a per operator basis, which is really cool. Once I add that recompile hint in, and my update of the table variable says with recompile, this gives SQL Server more insight into how many rows are actually in that table variable, and this changes its decision. It decides I am going to go to a wide plan. Our clustered index seek does 2.5 million logical reads, 2.4 and change logical reads. And when I go back and look at my clustered index update, yeah, we're getting that. Why are we having to do all this logical read I/O again in this case? So we can learn a lot from these execution plans, but the information is interesting because this wide plan is sometimes doing extra I/O. We also have a narrow plan we saw with the table variable that is very fast. So what we've got here is a complicated problem.